Hi guys, I'm going to do a little review video of the 3 different ways that we have learned how to solve systems. So I'm going to start with 2 different graphing. So here both the equations are in slope-intercept form, so they're ready to be graphed. So here my b value is 4, that's my y-intercept, and my slope is -2. So down 2, right 1. And remember, when you're graphing, try to make these pretty neat so you can find that exact point of intersection. Okay, the second one, my y-intercept is at -2, that's my b, and then a slope of -1/2. So down 1, right 2, down 1, right 2. So these intersect right here. Now, my final answer is that actual ordered pair. So 4, 4, -4. Okay, now notice these aren't solved for y, so I need to solve them both for y first. So I'm going to subtract the 5x over in that one, and in this one I'm going to subtract the 5x over as well. So let's graph them from here. So -2, and then if I go down 5, right 1, that's not going to really fit. So let's go up 5, left 1. For this one, my b is at -4, and it also has a slope of -5. 1, 2, 3, 4, 5. So these are really close together, but you should notice that they have the same slope. So these are parallel. So my final answer, they never intersect, is no solution. Okay? All right, let's do 2 by substitution. So these are both solved for y already, so I can literally take this one and substitute it in for y in the bottom one. From here now, I have an equation with just one variable, so let's solve for x. So I'm going to add 4x over. I'm going to subtract 6x, and then divide by 5. Now I need to find the y value that goes with that. So I'm going to plug that x in that top equation. So -6, I'm going to put in for that x. And when I solve this, I get y equals 0. So here my solution is -6, 0. You totally could have plugged -6 in the bottom one, and you would get the same exact y value. Now, to solve this via substitution, I need to solve one of the equations for a variable. So the easiest thing to look out for is a variable that has a coefficient of 1. So I'm going to solve this and make it y equals, I'm going to add that 7x over, and now I can substitute that in for y in the other equation. So I have -8x plus 2 times that quantity, 7x plus 11. Okay, let's distribute the 2 to both pieces. Combine like terms. So a -8x and a positive 14x gets me 6x. Subtract the 22 and divide by 6. Now, let's plug that back in. You can plug it in here, here, here. It doesn't matter. I'm going to plug it back in for x at this point. You should get the same y value no matter where you plug it back in. Oops, so -14 plus 11, so I get -3. So -2 comma -3 is my answer there. All right, let's do 2 via elimination. So if you notice, these are just like one. The whole idea is to eliminate a variable. If I add these together, it's like one big addition problem. Those cancel. Here I get 3x equals -3, and x is -1. Got to find the y value. So I'm going to put that x back in the top. It doesn't matter which one. So I have -2 plus 7y equals -30. Let's add the 2 over, divide by 7. So I get -1 comma -4. Now notice here nothing eliminates the way it is, but this is a -10. If only this were a positive 10, then they would easily cancel out. So if we multiply this entire top equation by 2, so let's rewrite this. I have -4x plus 10y equals -32. And then I'm going to leave the bottom one the way it is, the bottom equation. Now it's just like the last problem. Let's add it up. 5x, those cancel, equals -35. So divide by 5. Now let's find the y value that goes with that x. I'm going to plug it back into the top equation up here. It doesn't matter which one you do. And we get -6. So -7, -6. So things to remember, okay? if you have intersecting lines, you get one solution. Or like all of these, not that we graph them, but we got one solution, those would also be intersecting lines if we were to graph them. Okay, but we don't have to graph them. Okay, if you have the same slope but a different y-intercept, okay, those are no solution. And then if you have the exact same equation twice, they have an infinite number of solutions. Okay? And I know we saw this at some point in one of our videos. I think it was the first one. If you ever want to check to see if a point is a solution, so like for example, if I wanted to check to see if negative 6, 0 was a solution, you need to plug it back into both equations and make sure it works in both of them. Okay? So I pushed out a review for you to complete with a key and then a quiz. I hope you guys are doing well. Please reach out if you have any questions at any time.